Hi friends. In this video, we're going to talk a little bit about exponential equations and how we can go about solving things when we're dealing with variables that are in an exponent or in a power. So I want to think back to what it means to have a number raised to a certain power. So we of course know that any number can be uniquely made up by a set of prime factors, right? So the number 2, for example, is just 1 times 2, or just the prime factor of it is 2. The number 6, for example, is the prime factor is 2 times 3. Those factors, 2 times 3, can never create or be multiplied together to create a different number other than 6. Okay? And we're going to use that sort of fundamental understanding of numbers to be able to find a sneaky way to solve some exponential equations. So if I take a look at an exponential equation here, where I have the base of 3, I know that 3 to the 2x power, right? If this value is the same as 3 to the 5th power, then this side of the equation must be also the same value. It's got to have the same value as 3 to the 5th power. In other words, if the bases are the same, therefore the exponents must be equivalent. Okay, so here, since the base 3 and the base 3 are the same, I can write a therefore statement. I can notice that therefore this exponent here, 2x, must be the same thing as 5, because 3 to the 5th power, there's only one value. There's only one exponent that could give me 3 to the 5th power, and that's if this exponent is also the same as 5. So, well, if 2x is equal to 5, then it's easy enough to solve this. It's a nice linear equation. So I could just divide both sides by 2. And so x is equal to 5 over 2, or 2.5. Okay? And plugging it back in, I could check that understanding and say, is it true that 3 to the 2 times 5 halves, or 2.5, is equal to 3 to the 5th power? And indeed, here I get 3 to the 5th power, because those 2's cancel out, so I get 3 to the 5th power, which is equal to 3 to the 5th power. Okay. So as long as the bases are the same, right, as long as those bases are the same, then we can set those exponents equal to each other and use that as a maneuver by which to solve. Now, of course, it's gotta be careful. You've got to make sure that the bases are the same. In other words, it's all about the base. That's right, I went there. All right. So if I take a look here at this expression, on the left-hand side, I notice that the base is 2, but on the right-hand side, I have this number 32. But fortunately for us, I've already memorized my power to know grid, so I know that 2 to the 5th power is 32. I'm sure you have already done the same thing. So we can rewrite this as 2 to the 2x is equal to 2 to the 5th. Now those bases are the same. Okay. So the first thing we did, just to list out the steps here, the first thing we did was to make the bases the same. And then that means that therefore the exponents are equal. Okay. So if these bases are the same, therefore the exponent of this, the 2x, must equal 5. I wonder what it says about me that I chose the exact same values for this equation as for the last one. Okay. Let's try another one. Let's take a look. So here, again, my base is 2, but on this side, the 2 is in the denominator. So some exponent was applied here to take the reciprocal or the inverse of 2. And of course, remember from our laws of exponents that we just went over, that means that 2 to the 2v, and just rewriting this first time, is equal to, that's right, 2 to the negative first power, right, to get that reciprocal. If you don't remember how that works, check your notes on exponent laws. Okay. So now I've got the bases are the same. And so I can just come in and say, therefore, this exponent must be equal to this exponent. So dividing both sides by 2, v must be equal to negative 1/2. I can plug it in. 2 times negative 1/2 is negative 1. So that means 1/2 would be equal to 1/2. Let's make life a little more complicated for ourselves. Okay. Here, I've got a base that sort of was 6, but I've inverted it. So I can think of this either as 6 to the negative first power, or I could think of it as, I think I'll think of it as 6 to the negative first power. And then 6 to the negative first power is also being raised to the negative x power. Right? Here I have 36, which I know, of course, from my, shall I grab that powers to know sheet? I know that 36 is 6 squared. Okay. So now I need to remember a little bit about my laws of exponents, right? The bases are the same here, the sixes are the same. But if I have power raised to a power, I have to remember that I'm going to multiply those two exponents. So I have 6 to the negative first times the negative x, which is just 6 to the x, which is equal to 6 squared. Therefore, x is equal to 2. I can go back up and solve it, and I can say, is it true that 1/6 x to the negative second power is equal to 36? Well, is it true that 1/6 to the negative second power is equal to 36? And so this negative means take the reciprocal. 6 or 6 over 1 squared does indeed equal 36. Here we have a case where we've got different bases. Okay. But I can find a like base because I notice that they are both, again, I know this because they're on my, that's right, powers to know sheet. I know they're both powers of 3. So I'm going to rewrite this 9 as 3 squared. And then it's 3 squared raised to the negative 3x minus 1. That's equal to 243, which is the same as 3 to the 5th power. So now here I have a power raised to a power, so I'm going to multiply these exponents. Okay? So this is the same as 3 to the 2 times negative 3x minus 1. And that's the same as 3 to the 5th. So therefore, because my bases are now the same, I know that 2 times negative 3x minus 1 is equal to 5. So I'll just distribute and solve. So negative 6x minus 2 is equal to 5. adding 2 to both sides. Negative 6x is equal to 7. So x is equal to negative 7/6, or negative 1 1/6, or however you want to write that. Okay. I think I have one more problem here. Oops, I'm showing the answers. I'll move it off to the side here. Let's do just one more problem. So I like this one, so I'm just going to rewrite it here so I've got it. And so let's do 2 to the negative 2r times 4, which is equal to 1/8. So here I've got a couple of things happening on this left-hand side, right? I've got a multiplication problem, and then that's equal to a fraction. So the base, I need to get a like base, so I'm going to try to make the base here be 2 for everything. Okay, well this one's already 2, so I'm just going to rewrite this. 2 to the negative 2r. And I can rewrite 4 as 2 to the second power. 8 would be, or 1/8 I should say, would be 1 over 2 to the third power. So because that's a reciprocal, it's 2 to the negative third power. Now remember, if I'm multiplying like bases, the law says that I add the exponents. Okay, so here the base is 2 to the negative 2r. It looks a lot like a p. I really sort of messed that up. Okay, so that's the negative 2r. So 2 to the negative 2r. And again, if I'm multiplying like bases, I add the exponents, which is equal to 2 to the negative third. Okay, so now my bases are the same. So therefore, my negative 2r plus 2 is equal to negative 3. And solving, negative 2r is equal to negative 5. R is equal to 5/2. I can go ahead and plug it back in. So it would be, to check, 2 to the negative 2 times 5/2 would be to the negative 5th, times 2 to the second, or 4, may or may not give me 1 over, I'll just leave it as 2 to the third, or 1 over 8th. And so here I've got 2 to the second over 2 to the third should be equal to, oops, that was a dumb moment right there. 2 to the second over 2 to the 5th. I got ahead of myself because it's the 5 in this exponent, so that's the 5 in the denominator. Is that equal to 1 over 2 to the third? And yes, clearly 2 of these will cancel in the numerator, 2 will cancel in the denominator. So 1 over 2 to the third, or 1 over 8, is equal to 1 over 8. Okay, I hope that this helps to give you an understanding. I'm going to strongly encourage you to go back and review your laws of exponents and your powers to know sheet. It's going to take some work and review on your part to get good at these and solid at these, but I think that conceptually you'll be just fine with them. All right, I'll see you in class. Thanks.